Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 10.2. Problem number 10 is prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Right. Here you see angle between the two tangents drawn from an external point to the circle. So angle between the two tangents is nothing but this is your diagram. What is the angle between the tangents? This is one tangent and this is other tangent. So this is your angle between the tangent. Right. That is APB or BPA. Okay, both holds the same. This one and to the angle subtended by the line segment joining the points of contact at the center. Right. So this is the point of contact and this is the point of contact. Right. So the line joining the points of contact to the center. So this angle. Right. So here we have to prove that angle AOB plus angle BPA is equal to 180 degree. Right. That's it. So as per the same thing, you see OAP, this angle is equal to 90 degree. Why? The angle between the radius and the tangent is 90. Right. Similarly, OBP is again 90 degree. Right. So the same theorem, angle between the radius and the tangent. So when you look at this diagram, you see this is a quadrilateral, right? It has four sides. 1, 2, 3 and 4. So what is the sum of angles of a quadrilateral? It is nothing but 360 degrees. Right. So you just write down all the angles here. Okay. OAP. That is OAP angle A and APB angle P. Then PBO angle B. Then BOA. Right. So write all the angles and the summation is equal to 360. So we know angle A and angle B are 90 degrees. So just substitute the values. So 90 plus 90 gives you 180 here. Right. So again you keep these two terms as such and I am moving this 180 to the right hand side. So 360 minus 180 gives you 180. So that is, you see, angle APB plus angle AOB equal to 180 degree, which is nothing but supplementary. Right. Therefore, angle O and angle P are supplementary. This is the thing what we need to prove. Right. So problem number 11. Prove that the parallelogram circumscribing a circle is rhombus. Right. So there is a circle inside and there is a parallelogram outside. So a parallelogram circumscribing a circle, we have to prove that as a rhombus. Right. The same question can be told in a different way. You see, if all the sides of a parallelogram touch a circle, show that the parallelogram is a rhombus. Right. Both the questions, that is the answer is same for these two questions. Okay, both the questions holds the same meaning. Finally, we have to prove that a parallelogram is a rhombus. Right. Here they have used the word circumscribing. Instead of using circumscribing, here they have told that all the sides of a parallelogram touch a circle. Right. So we are having a circle, right? And we are drawing a parallelogram in such a way that all the sides of the parallelogram touches the circle. Right. Now, what do you mean by parallelogram? Opposite sides are equal. Right. So here in this parallelogram, AB is equal to CD. Similarly, BC is equal to AD. Right. So opposite sides of a parallelogram are equal. So what we have to prove? We have to prove ABCD is a rhombus. Right. So again, you see here by using our theorem 10.2. So A is an external point and AS and AP are the tangents drawn to the circle. So AS will be equal to AP. Similarly, B is an external point, right? And BQ and BP are the tangents. Therefore, BQ is equal to BP. And similarly, C is an external point, so CR should be equal to CQ. And finally, D is an external point, so DR will be equal to DS, right? So just write down all the things, right? So after writing this, here you just mention the reason, that is tangents drawn from an external point. Okay, tangents drawn from an external point to a circle are equal, right? So now we have to add these equations, add all these left hand terms together and right hand side terms together. So just when you add, again the same thing, AP plus BP plus CR plus DR is equal to these things, AS, BQ, CQ, DS, right? So AP plus PB, again look back at the diagram. So AB plus PB is nothing but AB, right? And again CR plus DR is equal to CD. So just replace accordingly. Okay, AP plus PB becomes AB and CR plus DR becomes CD. Similarly here, AS and DS together, right? So AS and DS becomes AD and BQ plus CQ becomes BC, right? So now you see, here we had made AB is equal to CD, right? So in the place of CD, just replace AB, right? So AB plus AB, which is equal to, here we are having AD and BC, right? So you see BC is equal to AD, right? So you see I am rewriting AD with BC. So BC plus BC gives you 2BC. So these two get cancelled, right? And finally we are writing AB is equal to BC, right? Similarly, we can prove that CD is equal to AD, right? So here you see AB is equal to CD, right? But here we have proved AB is equal to BC, right? So write all the things. AB is equal to BC and the same AB is equal to CD. And this CD in turn will be equal to AD, right? So therefore, here all the four sides are equal. Okay, that is the quality of a rhombus. Therefore, we have proved that parallelogram ABCD is a rhombus here, right? So here the key thing in this problem to be noted is, first you have to draw the diagram perfectly, right? Then the thing is, you have to mention this point of contact with some names, right? Then again AB is nothing but AP plus PB, right? Then BC, and again for CD and AD, just you have to substitute. Then because of a parallelogram, this is mandatory. Only with the help of this rule, we can finally prove that the parallelogram is a rhombus, right? That's all. If you have any doubt, let me know in the comment section. Thank you.